Picture this terrifying scenario. It's a Tuesday, your API is absolutely flying, blazing fast. Your CPU utilization, beautifully low. Every single one of your traditional engineering dashboards is glowing a happy, healthy green. But there is a massive, hidden problem. Your AI is confidently lying to your users. Where on earth do you even start looking? I mean, when your infrastructure is perfectly healthy, but your application is serving up confident hallucinations, the old ways of debugging just completely fall apart. Welcome to The Explainer. Today, we are diving headfirst into that exact nightmare by architecting an enterprise AI observability and evaluation stack. We're going to break down how to build a robust, multi-layered system that goes way beyond traditional monitoring. That way you can build AI that you and, well, more importantly, your users can actually trust. All right, here's our roadmap for today. First, moving beyond traditional software monitoring. Then, the AI quality paradigm, looking at the enterprise AI stack, connecting those stack layers, and finally, building trust through measurement. Let's get right into it. Starting with part one, beyond traditional software monitoring, and the massive paradigm shift we're currently in the middle of. Look, for years, software observability was honestly pretty straightforward. If an API slowed down, we checked Grafana. If an exception got thrown, we searched Graylog. It worked beautifully because traditional software is deterministic. You give it the exact same input, you get the exact same output. But enterprise AI, it completely shatters that assumption. Large language models bring probabilistic behavior into the mix. You can literally send two perfectly identical requests and get completely different responses. You could push a new deployment that actually improves your latency, but drastically tanks your answer quality. And the absolute worst part? A retriever might silently miss the most critical documents, giving your user a confident but completely wrong answer. And guess what? None of those failures will ever trigger a traditional application error log. Which brings us to section 2, the AI quality paradigm. Because the underlying technology has shifted, the questions we need to ask have to change too. When engineering teams start actually building production RAG apps, retrieval augmented generation, they hit this massive wall of frustration. They start asking things like, wait, why did the assistant just hallucinate that? Your standard monitoring tools simply were not built to answer this. They'll tell you the API took 200 milliseconds to respond, sure, but they have absolutely no idea why the AI just made up a fake product feature out of thin air. Or, you'll be scratching your head asking, which document was actually supposed to be retrieved here? This right here perfectly illustrates that silent failure problem. The AI might sound incredibly fluent, but if it pulled from some outdated 2022 PDF instead of your brand new pricing guidelines, that's a failure. But to your backend system, it just looks like a successful transaction. And then there's the operational side, the real business anxiety. Which model is chewing through our budget? Did yesterday's little prompt tweaks silently introduce regressions? Which conversations are actually getting terrible feedback from users? Notice how literally none of these questions have anything to do with CPU, memory, or API response time. They are an entirely new breed of questions about AI quality. So how do we actually fix this? Let's move to section 3, the enterprise AI stack and the 4-tool solution. Because a huge misconception right now is trying to solve all these AI quality headaches with a single platform. That might have worked for microservices, but it does not work here. We need a complete blueprint for reliable AI. Just like we use different tools for logging, metrics, tracing, and security in traditional software, enterprise AI requires a stack of specialized tools that each crush one specific problem. The absolute most effective stack combines 4 powerhouses: Arize Phoenix, Langfuse, DeepEval, right alongside our traditional bedrock of Grafana and Graylog. Let's break down exactly what each of these brings to the table. First up is Arize Phoenix. This is your go-to for really understanding AI quality. When an answer is just flat out wrong, Phoenix helps you answer the why. Instead of just staring at the final LLM response, it evaluates your entire RAG pipeline. Let's say a customer asks your bot which payment terminals are supported, and it whiffs it. Phoenix lets you actually inspect the evidence. You can finally see, were the right documents even pulled? Was the response grounded in reality? Did the retriever just totally miss the mark? You aren't just flying blind and guessing anymore. Okay, next. Once your application actually hits production, the game changes. It becomes highly operational. And that is exactly where Langfuse shines. You absolutely need to know what's happening in the wild. Which prompt version is actually crushing it with real users? Which customers are eating up all your tokens? And which model is driving up your costs? Langfuse handles all of that. Prompt versioning, session analytics, user feedback. From an engineering management standpoint, Tracking this token usage and latency is just insanely valuable for your capacity planning. Then we have our third pillar, DeepEval. And man, this is crucial because it finally brings CI/CD, continuous integration and continuous deployment, to AI. Think about it. One of the biggest lessons software engineering taught us years ago is never deploy without automated testing. But with AI, people change an embedding model or tweak a prompt and just cross their fingers. Without automated eval, you have zero clue if you just improved quality or quietly tanked the whole system. DeepEval treats AI quality exactly like unit tests. It automatically checks context precision, RAG correctness, faithfulness, meaning every single pull request gets a strict AI quality gate before it ever sees a user. And of course, the fourth pillar, Grafana and Graylog. We cannot forget the foundation. At its core, your AI application is still a complex distributed system. You still absolutely need visibility into your Kubernetes clusters, your Kafka streams, databases, and infralogs. AI observability doesn't replace your traditional bedrock. It just builds a smarter layer right on top of it. Which brings us to section 4, connecting the stack layers. Let's look at how all these pieces actually talk to each other as a unified system. So the real magic here is that these tools don't step on each other's toes. They create a layered architecture. If you're asking, is my infrastructure healthy? Boom, you look at Grafana and Graylog. If you want to know, what is my AI app doing in production right now? You turn to Langfuse. When you need to dig in and ask, are these AI answers actually good and grounded? That's Arize Phoenix. And finally, right before you ship, did my latest deployment reduce quality? DeepEval answers that. Every single tool contributes a distinct, totally necessary layer of confidence for your team. It cleanly separates operations, evaluation, testing, and infrastructure so they can all evolve independently. Let's move to our final section, building trust through measurement, and the big takeaways from this whole architecture. You know, after watching enterprise software evolve over the last 15 years, there is one principle that continues to hold absolutely true. If you can't measure it, you can't improve it. It's timeless. And that engineering philosophy applies just as much, if not more, to modern enterprise AI as it does to traditional microservices. You literally cannot just deploy an LLM and hope for the best. The catch today is that what we're measuring has completely changed. We aren't just staring at uptime and latency anymore. Now we have to measure accuracy, groundedness, faithfulness. We need to track retrieval quality and prompts performance. These new AI-specific dimensions, they are now every bit as critical as a server being online. Because, let's be real, if the AI is confidently hallucinating, nobody cares how fast your API is. Ultimately, what you are really measuring here is user trust. Which leaves us with this final, kind of provocative challenge. The organizations that are actually going to win at enterprise AI won't just be the ones with the biggest, flashiest models. It's going to be the ones who can confidently answer these 4 questions every single day. Is my platform healthy? What is my AI doing in production? Are the answers actually good? And did my latest release improve or reduce quality? Take a hard look at your own systems right now. If your team cannot answer those questions with cold, hard data instead of just assumptions, are you really building AI that your users can trust?